As more and more structural engineers connect to and embrace building information modeling workflows, there is increasing demand for analytical collaboration in BIM. Structural analytical modeling in Revit enables engineers to coordinate across physical and analytical models and drive BIM-centric analysis workflows within Revit. In Revit, structural engineers can leverage existing physical geometry in 2D and 3D views as context for the analytical model, and then decide the physical-analytical relationships element by element. The analytical elements are fully parametric and associated with grids and levels, enabling you to control analytical model positioning using these datums and others. When modeling analytical elements, you can assign their structural role, type and shape, define their cross-section rotation, and specify how these elements should be analyzed. To keep track of the relationships between physical and analytical model elements, you can easily associate them to each other. When this is done, associated elements can be easily located within the model, and this association can be utilized for automating synchronization of properties between physical and analytical models. Also worth mentioning is that structural engineers can associate multiple analytical panels or members to a single physical object, or vice versa. For example, several analytical panels used to represent a single physical floor, several beams associated to a single multi-span analytical member, etc. The analytical model can be associated to physical geometry, but at the same time, it remains independent, providing you with the benefits of speed and accuracy in model creation and editing while protecting the analytical model from unexpected changes. Revit provides engineers with a diverse range of tools for editing an analytical model, greatly enhancing the efficiency of the model creation process. You can perform tasks such as splitting, extending, trimming elements, and much more. With the modeling autonomy enabled by member and panel objects, the analytical model can represent not just Revit structural elements, but also generic objects, roof structures, stairs, compound geometries, etc. Revit also provides structural engineers the rules-based structural analytical model automation. This tool enables you to generate a structural analytical model automatically from selected physical geometry and vice versa. This solution ensures that the automatically created model is always consistent and connected, eliminating the need for tedious corrections and rework. As the analytical model is completely autonomous, it allows structural engineers to initiate structural analysis workflows from Revit without any physical geometry. Instead, they can start a new model from scratch and focus exclusively on aspects of analysis. Engineers can start modeling with analytical geometry and simply add physical geometry when needed for the construction documentation and detailing phases. This workflow is especially well suited and applicable to projects where engineering requirements dictate the design. Depending on the load duration and type, different natures of loads can be created. Then various types of loads such as point, linear, and planar loads can be applied to a structure and assigned to previously defined load cases. These loads can be easily and accurately applied to specific areas of panels and members or copied to other analytical hosts. Revit's unleashed versatility for defining analytical model geometry enables true bidirectional analysis software workflows and capturing edits made in other tools while eliminating modeling limitations. This BIM-centric approach to structural analytical modeling offers many benefits to structural engineers. you can more easily create representations for any type of structure: buildings, bridges, frames, pavilions, stairs, and more. You can create consistent analytical models that align with their preferred engineering approach. You can enable structural analysis jobs from Revit models. You can even create multiple analytical models for a single physical representation and consider various analysis approaches simultaneously.